Okay, do we have a factored form? Let me copy it one more time here. Okay, do we have a factored form for the top? Okay, I only heard one yes, so let's do it together. 2x squared minus 9x plus 9. It's a trinomial, it's in descending order. There is nothing I can factor out, and the leading coefficient is not negative. So it's not a special product because this is not a perfect square and this is not a perfect square. So then my only possibility is to multiply these two and I get 18, and then the sum of negative 9. So I'm trying to find two numbers. Yes? Yes, I would say yes if the leading coefficient were 1. But since the leading coefficient is not 1, the numbers are correct. It's negative 3 and negative 6. However, I have to replace this. This is a long procedure. It doesn't have, I cannot write the factor form right away. So I have to write 2x squared minus 3x minus 6x and plus 9. And now the procedure is called factoring by grouping. So from the first two, I factor out. Good. What is left in parentheses? One more time. 2x minus 3. What should I get from the other two? I refuse to look. It has to be 2x minus 3, and now I look. I need the sign, the correct sign, and the factor. Do you all agree with minus 3? Now the common factor comes out, which is right, and in parentheses?
That's what he said.
Oh. But he, well, I'm sorry, I apologize, but I wanted to show all steps. Sorry about that. Okay, so then we have the factored form as 2x minus 3 and x minus 3. Now the denominator is, right, 2x minus 3 indeed, divided by, the numerator is x times x minus 3, and then 2x. How many restrictions will you give? 2. X not equal, x not equal. Good? Good. We all agree with that? Now, I am allowed to simplify in a division, not across, but I'm allowed to simplify the fraction by itself. Always. That I'm always allowed to. So then, I want to get rid of this and get rid of this. And I want to get rid of this and get rid of this. You cannot simplify across in a division. You can in a product. So then, I continue here, and I have x minus 3 over 4 multiplied by 2 over x minus 3. Do you agree? Because there is a 2 left in the denominator. Now, I have one more restriction to add here. Yes, x cannot equal 3. And now I'll simplify x minus 3 with x minus 3. Please write 1 when you simplify. And 2 by 4, and I get 2. So what is the final simplified form, assuming these restrictions are fulfilled? 1/2. If you don't write 1, you may think that that's a 0 up there, and you'll say 0 over 2 instead of 1 over 2. So I wanted to avoid that. Any questions on dividing? Yes, please.
How come, like, does it matter what the sign is before we go to multiplication for the last step? Because, like, when, like, you're dividing between them, and then the very last step, it's like you just multiply them. So it doesn't really matter what sign we start with if we handle it the same way.
Does it matter what sign?
Yeah.
Let me see. Because I'm not sure. Yes, but you're, yes. So the question is what? Yes, because if this is multiplication, then you would never have to flip this. This is very important. You only flip if it's division. You're talking about not the sign, but the symbol, the operation. Yes, if it's not division, then I will not be able to flip it. So it's crucial. Yes, very good. Good. Let's move on to a multiplication. And I would like to look at 23 on page 506. So x squared plus x minus 42. Everything divided by x minus 3. And this time is multiplied by x minus 3 squared divided by x plus 7. We need more time on 23? Okay. Okay, 23. The top of 23, top of the first fraction in 23. Excellent. So now I'm ready to simplify. After I state the restrictions, I have green light. Can I simplify anything? Right, ready? 1x minus 3 with 1 from here. That's why I put 1 here, because there is nothing left other than 1. And then x plus 7, 1 here and 1 here. Do not distribute. So the final simplified form is assuming all conditions are fulfilled. Good. For this function, we're asked to find domain. So let's find the domain for function g of x equals 20 divided by 3x squared minus 48. Okay, can anyone give us an idea here?
Zero.
Thank you. I will divide both sides by 3 because that will not change the solutions. I will, what do I do with x squared minus 16? Good. Now we're ready to state the domain. Can anyone state the domain, please?
-4 to 4.
In plain English, anything but 4 and -4. Please remember this is crucial. Okay, 14. Here we are only asked to factor and simplify, not the domain. I'm kindly asking you this weekend to find the time to print out a blank copy of test 1, a blank copy of test 2, a blank copy of test 3, and solutions if you need them, or just save them on your hard drive or flash drive, and redo those problems. It is crucial to use this weekend to review at least once. Reviewing in class twice is not going to be good enough. But if you redo this weekend, all 3 tests, if you redo the next weekend, all 3 tests, and the following weekend, all 4 tests before the final exam, you will come into the final solid. Please find the time to do that. Can anyone get us started on this? Yes? Excellent. Very good. Sum of cubes. Excellent. So now I have 2 restrictions. From here, I cannot have x equals, and from here, I have this cannot be 0. But this, when we solve it, when we set it equal to 0, and we find that it has imaginary solutions, you know that this function has a minimum or a maximum. It's a quadratic function with a minimum or a maximum. Right, it looks like this, and it never touches the x-axis because the solutions are imaginary. So there is no restriction coming from here. This will always be true. X squared minus 2x plus 4 will always be true. Will never be 0. So I would like to show this. Very easy to show. Here it is. So if you want to plug it in to check that, what I'm just saying, you plug in x squared and then minus 2x and then plus 4. And I will choose, I don't know, I didn't calculate anything, but looking carefully, negative b over 2a will be 1. So the minimum will be when x is 1. So I will choose the standard, that's fine, and then graph. It's above the x-axis, and it turns and it has at exactly at 1 when x equals 1 and y is 3. So this can never have solutions. So in other words, x squared minus 2x plus 4 is always never 0. So there is no restriction coming from this. Since it can never be 0, there is no dispute, no problem there. Okay. I'd like to start reviewing chapter 12. Okay.
I have a question.
Yes, please. Yes, please. Yes.
The whole concept of the functions like f of g
Yes.
blows my mind.
Okay. Very good.
Like I for some reason, I can't get to sink in.
Okay. Let's talk about that.
Okay.
Let's start with that. We understand that we can create functions by adding two functions, subtracting two functions, multiplying and dividing, right? We know that. There is a fifth way. And here's how the mechanism works. You may have missed this particular class. Maybe that's why. Okay. So if I pick a number here, so this is a domain, right? A function domain. If I pick x, and let's say I want to apply a function to it. Let's say the function is called g of x. Well, I shouldn't write g of x. I should just, for the sake of the argument here, I should only say I apply function g. You'll see in a minute why. So when I apply g to x, you can say you get a number. But let's say in general, if I apply g to x, what do I get? Do you agree with that?
Yeah.
Right? Is that okay?
Yeah.
Good. So for any x, when I apply g to it, I will get g of x. This is a number. I apply a function and I get another number. So far, so good?
Mm-hmm.
And now to this number, let's say I want to apply another function, which is f. So this is a number, and I apply f to it. What will I get?
F of g of x.
That's it. F of g of x. This function is called, because g is applied first, g must be the closest to x. G is the inner function. Inner. Outer. So that is your f of g of x. And this is the notation. And it means exactly what you said, f of g of x. But I have to remember also the idea that the first function I apply, it's called the inner. This was the first function we applied. We applied to x, we applied the inner function. So when we are done and we found the number, then we applied the outer function. Let's suppose I'm given two functions now. This was the theory behind it. And now let's apply it to, yes, please.
I was just gonna say, so what you're saying, like if f of g of x, say f of g of x equals like 2, and f of x would be like 2x, and g of x was 2.
No.
And you just,
This is not the way I look at it. I have to be given the function f and the function y to determine f of g of x. I cannot go backwards. You cannot say, hey, here f of f comma g is, or f of g of x is 15. Come up with f and g. I can't do that. I cannot work backwards. Let me explain why. Let me give you an example. It's a very good point you're making, by the way. Very good question.
those are the questions that you have to ask to do that. I was like, what?
Okay, so let's say I have f of x equals 2x squared plus x minus 3. And let's say I have g of x, which is x minus 1. And let's suppose I'm asked to find f comma g, that's the notation, which we know now this represents exactly what Daryl said. He said f of g of x. Which means, instead of g, don't cross it out like that, I'm making a point. What should I replace this quantity by? Do you all agree that this is indeed f of x minus 1? Is this okay so far? But now I stop for a moment and I look at f. F tells us this. F of whatever equals 2 times whatever squared plus whatever and minus 3. One more time. F of whatever equals 2 times whatever squared plus whatever minus 3. Now this is whatever. This is my whatever. So this goes in here and goes in here. Can anyone dictate? 2 and quantity, x minus 1 squared, very good, plus, yes, with parentheses or not, minus 3. Now we made a contract on this 3 months ago. When you square x minus 1, you will get how many terms? Please do not say 2. I don't want to hear 2. We will have 3. Very good.
So it's x squared minus 2x plus 1.
Good. Plus x minus 4. I distribute 2x squared minus 4x plus 2 plus x minus 4. I combine like terms, 2x squared minus 3x minus 2. This will be absolutely impossible if I would say to you now, here is f come g, come up with f and x. I'm sorry, come up with f and g. You can't.
That was high school math right there.
Impossible.
Exactly.
Absolutely impossible. Nobody from here can come up with f and g. It's a very good question, but it's impossible. Is this better about f come g? Daryl, do you feel better?
Oh, yeah, can we just leave that up for a moment?
Oh, yeah, yeah. But is it better?
Yeah, absolutely it is.
Now, there is another question that I would like to ask. Let's say we have an uppercase f of x, which is the cube root of x plus 2. Now, if I ask you to decompose, please decompose this function into an inner function that we will call g. So I'm going to say g of x is the inner, and f of x is the outer function. And allow Daryl to think for a moment, so make sure that everything is clear now. So here's my question. If you were, let's say, to evaluate this function for 15, which function will you evaluate first? So from my bubbles, if we're asked to evaluate for 15, x equals 15, so this is 15, you apply g to 15 to get g of 15, and then you apply f to whatever this is to get that. So can anyone say what, or Daryl, if you want to, I never call on anybody, but unless they are disrupting. Can anyone give us the inner function that you will evaluate first if you were to evaluate uppercase f at whatever number you want? Which function will you plug it in first? Right. So first I have to evaluate this portion for 15. Once I get a number, so this will be the inner function. I evaluate this one for 15, then I get a number, which is 17. Which function I apply to 17? The cube root of x. So the inner function then will be x plus 2. Once I get a number, which function on this number, which function I apply on this number? The cube root of x. So now if you want to determine f come g of x, you will get the cube root of x plus 2. Are we okay with that?
first number that interacts with x, we just assume that's it.
Yes, you can assume that the inner function is just x. You could. So once you get a number here, then which function will you consider the outer function? Exactly.
So there's multiple ways.
Right. Yes. Yes. Any questions? Let's decompose one more. So let's say this function, uppercase f, which is 1 over x plus 1 to the third. This time I want to decompose it into 3 functions. I want f of x, I want g of x, and I want h of x. This is the innermost, I should say, inner, outer. Which function will you evaluate first if you were to evaluate this function for 15? Right, that's the innermost. You are done. X plus 1 is just a simple number, one number. Which will be the next function you apply to that number? You're done. X cubed now becomes one simple number. Now you get one number from here. So this is one number. Which function will you apply next? Is this better? Should we choose another or not? Okay, very good. So let's say f of x equals the absolute value of x plus 1 plus 3. 3 functions or 2 functions, whatever you want. I'm happy with 2 functions. You can use 3. If you want to use 3, then you will give me 3 functions. We start with the innermost. Next function, when you're done and you get just one number in here. And after you're done with that, so you will have x plus 3. Very good.
How come you don't change the variable if you're going to like, if you just keep it as x?
Right, because f and g have variables x. I can't just say that this is x and this is y, because I won't ever be able to plug them in. Right? So if I have g of y here and y here, then this will not exist. Good? Okay, I'd like to look at some logarithmic equations. Let's say problem 60 on 774. Log base 3 up to x plus 5 is 2. We're working on this. Then we are working on this. Okay, so this is definitely a logarithmic equation. Would you agree?
Yes.
I have to state a restriction. Log is not a friendly function. What is the restriction that I have to write? 2x plus 5. This is log applied to 2x plus 5. 2x plus 5 must be greater than 0. Remember, log is a function with restrictions. It's defined from 0 to infinity. So then, therefore, x must be greater than negative 5/2. If the answer I get is not greater than negative 5/2, what will I say about this equation? No solutions. Okay, so now I know that this is equivalent to, can anyone dictate? Equals? Very good. But how much is 3 squared? So then this equation becomes 9 equals 2x plus 5. It's linear. I subtract 5. So this is 4 equals 2x. Therefore, x equals 2. Is this in the domain? Good. So it must work. Now, this problem, the formula is given to us, and we are told we have $5,000. We wanted it to grow to $10,000 at an annual interest rate of 8%, with the interest compounded quarterly. So what do I do? Equals 1 plus 0.08. Interest compounded quarterly means how many quarters are in a year, correct? And raised to, n is the number, yes, 4 times t, right? Unknown, how long it takes. And I'm going to say, wrong problem. Wait till or until 141 or 151. I picked the wrong problem. I picked the wrong problem. I'll show you how to solve it because I picked it, but we don't know how to do this yet. So I will have to divide both sides by 5,000. So this will be 2 equals, I have to perform these operations or not, but it doesn't matter right now. So this is 0.02, right? So 1.02 raised to 4t, and we don't know how to do this because 2 and 1.01 cannot be presented with the same base. So what we do, we apply natural log to both sides, and then we have natural log equals 4t. That's a property that we haven't discussed in this course yet. And then I have t, which is natural log 2 over 4 natural log 1.02. So we don't know this. So I picked the wrong problem because, as you know, in chapter 12, my department selected certain sections, not all. So wrong problem, I apologize. But here's the correct problem now. So you can find this by putting in the calculator, and then you will see that that's the exact time you need, number of years, so that your investment from 5,000 grows to 10,000 with an interest rate of 8% and compounded interest 4 times a year. So now I'm going to pick the correct problem. Find the amount accrued if the principal is $1,600, invested at 9%, so R equals 9%, but it has to be changed into 0.09. Compounded semi-annually, what semi-annually is, and T equals 7 years. So N equals for semi-annually. This is problem 41 on 773. Semi-annually. How many halves are in a whole? 2. So then I know A equals 1,600 in parentheses, 1 plus 0.09 divided by 2 raised to 2 times 7, which is 14. This we know how to do in this class. Sorry about that. Sorry about the confusion. So then I put it in the calculator. So in y, no, not even in y equals. So we have 1,600. Open the parenthesis. 1 plus 0.09 divided by 2 and everything raised to a power, put the caret in parentheses. 2 times 7 you can perform, and that's 14, and close the parenthesis and press enter. So it will grow, the 1600 will grow to 2963.11, approximately $2963.11. If the interest is compounded twice a year and the interest rate is 0.09 or 9%. And I can calculate that previous problem. I don't want to waste your time, but I'm sure you're probably wondering. So natural log 2 and divide by, in parentheses, everything in parentheses, 4 multiplied by natural log at 1.02. So I got 8.75 years, so roughly 9 years. Of course, you're not going to see this in your test. So roughly 9 years. If you want to go back and check, we can multiply and put 4 times 9 in there, and I'll show you. We'll get roughly, not exactly, because I approximated. So we get 5,000 and 1 plus 0.02. I had that anyway. In parentheses, to the power of 4 times 9, 36. So the answer has to be a little bit more than 10,000 because I rounded up. Sorry for choosing the wrong problem. Okay, one more for today. I would like us to find the inverse function for number 28 on page 773. So r of x is 13x minus 5 over 2. We are asked to find the inverse function of x. I have to say it, don't drink and drive.
Okay.
I have to remind you, don't drink and drive.
Alright. It's good to know. Better know otherwise.
I always remind my students before a holiday, don't do anything that I wouldn't do.
Well, how would we know what you would or wouldn't do?
I wouldn't do anything. Just breathe, stay at home, and study.
Don't look at nothing, don't touch
If you have any questions about what you're tempted to do, call me. And then I'll say, don't even tell me, it's no. Okay. Okay, number 1, step 1.
Is this the one where you replace?
Yes,
So, X, Y.
very good. Step 2. Yes, we are allowed to swap because we are looking for the inverse function.
And then solve.
Good. For y? Because y becomes now, okay.
So 2x plus 5.
Yes, because we know now this is a proportion. So 2x equals 13y minus 5. Yes. 2x plus 5 equals 13y.
Your magic on it.
See how good I am? You don't even have to tell me more. I got it. So in step 4, this is indeed what I'm looking for. What am I looking for? Yes. the inverse. If I were to graph these two functions, they would be on the same Cartesian coordinate system. They would be symmetric with respect to the line y equals x.
Stop. Stop interrupting her. I tried to remember.
Very good.
Sorry.
Happy Thanksgiving. I will see you on Monday. On